I thought he was going to say people who care about users and then also me. Here I am, styling the intrinsic web. This is a bit surreal. I, haven't left the house in a while. It's painting of me from earlier this month. Yeah. Since I was here last, I did get to join the CSS working group. And that's immediately when the US went into lockdown, so I'm very sorry about that. That was my fault. But I guess I'm here to talk about the future of CSS, but in order to understand where we're going, we have to talk about where we are and how we got here, the present and the past. In my mind, CSS exists for two primary reasons. The first is that it allows us to describe reusable objects. So when I'm doing print design, like the cover of a book, I know everything going into it. I know exactly what content has to be there, what I want it to look like, how it's going to come out. And when I get the final piece, there it is. It's exactly what I designed, and it's never going to change. You can click on it as much as you want, and it just sits there. But on the web, we're obsessed with new content. There's always new content. And it sucks if you have to restyle every single object as you add it to the page. This is what prehistoric developers had to do, or at least that's what I hear. It's not like I was there. But then we got CSS selectors, and they allow us to select all the paragraphs at once and make them all blue, which is exactly what we do. And then we can use classes and attributes to combine them into objects and entire design systems and component libraries, even somewhat shaky. That was a great talk. And people like Nicole Sullivan back in 2009 and Natalie Down in 2008 really helped us take a systemic approach to this and think about how we build these objects and systems in a really systemic way that is sustainable and can scale. But selectors have a problem. They can conflict with each other. So we can say that this link should be teal, violet, and orange. And we're allowed to say that. And somehow the browser has to find for every element on the page, for every CSS property that exists, there has to be one value for that property on that element, everything on the page. So we need some sort of system that allows us to put all of these styles into an arena and have them fight it out. Ideally, Tina Turner is there. And this is called the cascade with sheeting action. I stole that slide from Natalie Down's 2008 talk. It's a great talk. It's still worth checking out. So the second thing that CSS is for is it describes responsive styles. And not just responsive to the size of the viewport, which is cool, but also to user preferences. To quote or paraphrase Kate from earlier, the real advance in accessibility is providing options and adapting to user preferences, and that's built into CSS as a language. But also adapting to device interfaces. When Sir Tim and the team at CERN designed the first hypermedia browser, which there's an emulator, you can go check it out. It's a lot of fun to play with. They built it for the Next machine, which has this fancy futuristic graphic interface. Pretty cool. But you can't make a web that's worldwide by saying that it works on my machine and everyone else is an edge case. So they immediately built a second browser that's worse. It also has an emulator you should go play with. It's a lot of fun. And it works from any terminal with an internet connection. So at that time, I wasn't paying attention. I'm still barely paying attention. Although tech is getting cooler. I mean, have you seen all the stuff on this table? I wonder if he minds if I'd press buttons. I was busy writing my first novel, The Mystery of the Missing Art Box, which then led to my breakout hit, The Sward. I really wanted to be an author. But this became the mission statement of the entire web, and it still is. Web for all, web on everything. And that means, sure, your big 5K monitor, also assistive tech, also all these whatever, watches that are also helicopters, like everything. The web is on everything. It's not even guaranteed that it's going to have a graphic interface at all. So what does it even mean to design for that? Everybody has input. The user agent or the browser has input. Users have input. We have input. And we're all styling this together. We're designing for unknown content on an infinite and unknowable canvas that's going to be displayed across operating systems, interfaces, writing modes, languages. Like, it's absurd what we're trying to do with CSS. Not only is accessibility a team sport, but the entire web is a team sport. And that's why there's two of us up here, although he's not giving me a lot. Thanks, Toby. I don't remember why I have this slide here. Oh, it would be... This is why speakers have notes, isn't it? No, I mean, it would, like, to try to do what we do for print design and try to just take that over to the web, it doesn't make sense. It doesn't work. It's a totally different approach to media. The fact that we control the paper page is really a limitation of that medium. Like, paper just sits there, and you can click it a lot, and nothing happens. Still just paper. There are too many variables for us to consider all of them. There's no way that we could design for every single possible thing that's going to happen to our site. So we don't try. We develop systems. And the point of CSS is to make it so that we don't have to worry about all those different factors. It's going to help us figure out some of that automatically. Even things like normal flow, which we just sort of think of as just the way the browser works. It's just the default. You can think of it like a layout system like Grid or Flexbox, but it's the default. This doesn't work in InDesign. You can't just change a box and have boxes stacked together inside of it and text flow inside of that. And as I add new text, it adapts. That's pretty special. So our job in writing CSS is to define a few constraints and let the language work out the details because it's smarter than us. We provide hints and suggestions that the browser may or may not use. This is from the initial CSS proposal, which is also worth a read. And then we feed that into the all-knowing browser, which is the only part of the system that has all the information. It knows everything about the device you're on, and it knows the user preferences, and it can put all of this together in a way that we can't with sheeting action. So what is the cascade? I heard it has something to do with fish. Or Tina Turner. Put Tina in the browser, you cowards. So it is this thing where the browser needs some system, some arena for narrowing down to exactly one value for every property on every element. And the cascade is the part of this system that filters out if there's extras. If there's a conflict, we need to narrow it down. The cascade does that. And then after the cascade is done, if there's any open spots, inheritance fills in what's missing. There's a few other steps in there. But the cascade has all these layers: origin and importance, shadow context, element attached styles, cascade layers, we're going to get to that. And then selectors and specificity, where we spend most of our time, is really just this little bit down here near the end. And then order of appearance. And each layer works on its own, somewhat similar to this coin sorter. Like, your styles slide down and they get sorted into these categories. And then actually, we just ignore everything that's not in the largest category that has coins. Everything else is gone. And if we have more than one still, we need to move on to the next step and find out if there's anything left in that step. So it's sort of nested coin sorters all the way down. I didn't know how to make a graphic of that. It's an ordered list. We start with an ordered list or a cascade of style sheets from the user, from the browser, from us. And the user and browser sort of set initial global preferences, what they want across the entire web as a good default, and then hand the remaining influence over to us. We're coming in at the end of the process. And these are called the cascade origins, the user agent or browser. Users, these days not writing style sheets usually, but still setting preferences, and preferences in the browser are treated very much like user styles. It's just a graphic interface for the same thing. And then we come in with author styles. And, you know, sometimes these conflict too. The browsers are still giving us this 8-pixel margin that Mosaic came up with, and nobody wants it. Stop! I don't want your 8 pixels. So there's always a fight about that. In my mind, it's a little argument that we're having every time. And these get stacked together. So the user agent or browser goes first and sets defaults across the entire web. And then users get to add preferences on top of that. And user preferences override browser defaults. And then we come in at the end. And by default, we override everybody. But this isn't how it's supposed to work. In that initial proposal, Howcom says, if conflicts arise, the user is supposed to have the last word. We're just there to attach style hints for what we want on our site. And this is where important comes in. Importance is the balance of power between origins. This is the whole reason for it. It was basically so that legal text stays above whatever size you assholes come up with. And so importance adds these 3 new layers on top. And it's this back and forth system. So we get to override everybody by default, but then as soon as they add importance, they can protect their styles. They jump ahead of us in line, and the user gets to override us, and the browser gets to say some things are out of bounds, and they do use it. If you look in user agent style sheets, there's a few places they use important, and it's just stuff we're not allowed to touch. It wins. So there's sort of these 2 cascades, the normal cascade of origins that's great and we're in charge, and then the cascade with a fake goatee. And so a lot of these are actually sort of split along those lines. You go down a different side depending on whether there's importance involved. So there's a few other origins here for transitions and animations that were just added later to take care of where those should fit. But then you can see there's the important origins over here and the normal origins over here. Same thing with shadow context. This is dealing with shadow DOM. In the normal cascade, the outer page gets to override the shadow DOM if it can find a way in. And then if importance is involved, shadow DOM takes over. Element attached styles, this is inline styles. They're actually the same on both sides, but again, they're separate. For each, importance wins. And we'll see how that plays in with layers in a bit. So importance isn't there for us to get mad at somebody and override their styles the way that we often use it, but it's there to protect styles from somebody coming along later and taking away something that's important. We get to mark certain things and say, this should be protected. More importantly, users get to do that, at least in the browsers that still allow it. But I understand, we're just sitting there in the middle, and the rest of the system happens somewhere else. So we're mostly just lonely in our two origins side by side. And when we add importance, it doesn't change much. It just means we get to override somebody on the design systems team. Show them. Which gets us to CSS selectors and specificity. That's where we're spending our time, because we're not thinking about, we're often not dealing with shadow context, we're not thinking about origins, we're hopefully not using too many inline styles, so we're mostly dealing with this realm. And specificity is a heuristic, which is basically like an educated guess of what we might want to rank certain styles above others. We need these selectors, so we might as well have some way of getting some information out of that in terms of priority. So they're grouped into classes, and like the origins, they override each other, and they sort of have different intents. So we've got the universal selector that styles just everything, and that's pretty unspecific. So it doesn't have much specificity. Then types, like the tag that we want to style, and then classes and attributes. IDs are single use. That's pretty specific, so they win in the end. So we've got one for doing global defaults, and then we can sort of build common patterns on top of that, and finally get to singular overrides. But out of all of those, and here they are stacked up with IDs on top, those sort of attempt to match the layers of intent that we have in a style system. This is from Harry Roberts' inverted triangle, although I don't know why the triangle is inverted. So I like to flip it back over and have my overrides at the top where they override things. This just makes sense, Harry. But we're sort of trying to stack up these layers in the design systems that we're building, and hopefully those selectors can match roughly. Oh, if you meet Harry, you'll get a sense why it's like that. But these assumptions fail. It's an assumption, the heuristic of specificity. We don't have much control over it. We're just trying to select things and style them. And to have our entire cascade based on a guess is kind of shaky, especially as our projects grow and become more complex. Just a heuristic's not going to do it. So even in, this is from the browser style sheets, that's pretty specific for a default. Like you would need, if origins weren't separated out, you would need quite a bit in order to override those styles. And it's just a default border on a table cell. So the heuristic is failing here. It's a default that's too specific. And we also have things that really should be a little bit more powerful, and they're generally not. Hidden display none usually is easy to override, too easy to override. And within all these different layers of specificity, only one of those is really reusable and custom, something that we have control over. So we spend all of our time arguing over how many classes and how many attributes and how exactly do we use them, and don't touch the others. And we're trying to, I flipped it over again. I'm not an idiot. We're trying to match this rough sense that the more explicit we get, the more targeted we are, the more specific it should be, so that this heuristic works for us. It's a pretty good system that Harry talks about here. Is that Harry? Hey, hey. Um, yeah, it's right side up now. So importance, I got off. Oh, right. So we're trying to like line these things up and make them roughly match our layers. And then somebody throws importance like a grenade, and or just because somebody else isn't following the same set of rules that we are, Bootstrap, everything falls apart. And this sucks. This isn't a great, like, we're trying to do all of this, and our control over the cascade is this one layer of the thing. So we're trying to change that. We've actually changed it. Cascade layers rolled out earlier this year, and they give us control over our part of the cascade. That's what they're for, so that we can actually set up exactly these layers. We just took Harry's idea and put it in the browser. Just done. So we're creating layers of specificity, and you can do that with the @layer rule, which is a block rule like @media or any of those other rules, and we can put styles inside of it. And we can give it a name. We don't have to, but we can. And we can put styles in there and say, here's some styles that go in our generic layer, and they're going to stay there. And specificity is contained in that layer. And we can also throw importance in if we want. We can also use layers on entire style sheets that we're importing. So we can import a URL and give it a layer. And we can combine these things. So here's import a reset and put it in the reset layer. We can have different layers that we're creating, and they'll stack up together. And we can create any layers we want, and as many layers as we want. We can do exactly the inverted triangle right side up. And we just define each of the layers and put some styles in each one, and they get their ranking. And we get our inverted triangle right side up. And the specificity is contained. So if we're looking within a layer, it works the way we expect. So here, the menu drop-down item hover will override menu item because it has a higher specificity. But if we split those into two separate layers, now our menu item is going to override the menu drop-down item hover because specificity is ignored and our layers take precedence. And we can add to existing layers. So we can have the same layer come back multiple times, and those will all get merged together as though they're in one place. And if we repeat them in different orders, the order stays the same as the first way we encountered a layer. So layers are ordered by the first time that they show up. And we can also establish layer order up front, because this is a really helpful way to do it. We can just, in one rule, say, here's all the layers, here's the order that they should be in. Overrides are at the end, they're going to override everything else. Generic is at the beginning, everything else gets to override that. We've defined the entire order in one place, and then we can have all of our style sheets, and everything will just go where it was told to. So we can then have our code in any order we want, and it will still follow the rules that we established at the beginning. And unlayered styles have the highest priority. This is because sort of the first use case that you can think to use these for is like, let's throw a reset in there, and then let's throw a framework in there, and then our styles will override the framework and the reset. So unlayered styles build on top, although I think long term we're maybe moving towards put everything in a layer. It's clearer. So things get reorganized. So we can have a mix of styles in any order, and then they get sorted into their layers. This is sort of things at the end having priority, or we can flip that triangle and see things at the beginning have priority. Unlayered styles are going to win, and then we get our layers in order from there. And we can nest them. So we can put a layer rule inside of a layer rule or inside of an import that we're putting in a layer, and we can access those using a dot notation. So tools.custom from the outside references the custom layer inside of the tools layer. And we can do the same sort of thing here where we put a layer rule inside of a layer that sets up what are all the sub layers, what order are they going to go in. What's this for? I already talked about that. Yeah, and we can combine all these things. We can import an entire framework into our tools layer, and then we can add our own layers to the tools layer inside and easily override them. And importance works the way that it does with Cascade Origins, the way it was initially designed. It reverses the order. So we've got our normal layers, resets, themes, components, and then important layers jump to the top. So again, layers are now there to handle what we've been using importance for. When we get mad and just want to override somebody, use layers for that. Importance is there when we're in a lower layer. Say we're making a toolkit, but it's important that the dropdown is position absolute. We need to protect that. It's not going to be a dropdown anymore if it's not positioned. So we can protect that and say future layers that normally have higher power should not override this. And we don't have to fight those frameworks anymore. We can actually just put them into layers and put other layers around them where we want, or even sort of inside them, and override Bootstrap without worrying about what they did in terms of specificity. And we can also use this inside of components. It's doesn't have to be just a global thing. We can say, here we've got some buttons, and whoop, it downloaded that and got me way off. Huh. Present. There we go. So that's a little bigger. Yeah, so I've used layers here just to create for my button component. They have sort of base styles, and then they have theme styles, and then they have state styles. And I wanted to make sure that the state always overrides the theme, and the theme always overrides the base. So that's what I did here. And it just works, even though they're all different. Well, these are all the same specificity, so if the layers weren't involved, the order would matter, but it doesn't. I can rearrange them, and because I've set the order at the top, it doesn't matter how I rearrange them. They're always going to override each other in the same order. And that's now supported basically everywhere. I heard IE is dying, so this came out very quick. Browsers have gotten really good at doing this, like release them all within a couple weeks. It's pretty cool. So that gives us more cascade control with fewer hacks. And we're not letting assumptions just boss us around all the time. We actually have some control there. I wrote a deeper dive article for CSS Tricks if you want to check it out. And my team just released this article about the polyfill that they helped build. So if you need a polyfill to make layers work on older browsers, you can go check that out. It actually pre-builds everything, so it doesn't have to run in the browser. OK, let's move on to the next feature, scoped styles. So again, looking at like what are people trying to solve with selectors that we could actually just put in the browser. There's another reason that BEM syntax has sort of taken over, and it's this ability to avoid naming conflicts across distributed teams while also expressing membership through lower boundaries and proximity. So there's a little bit of a difference between a title and a title that's in a post and a title that's attached to the post. This idea of not just inside of, but belonging to is something that BEM tries to express. Or we have automated tools like view scoped styles that try to get at the same thing in a sort of automated way. It's hard to read. And we're sort of talking here about lower boundaries too. It's like we can have this media object, and then we can have media objects inside of that. And we want to just style one of them without styling the things inside. So we want a lower boundary that says this no longer is owned by the component, it's just inside of it. So that's a little different from Shadow DOM encapsulation 2. The Shadow DOM encapsulation is this sort of hard boundary. Nothing gets in or out, and it's attached to the DOM, like it's a specific element that things can't go through. And what we're trying to do is more like what Vue or BEM or CSS modules is doing, where it's not that nothing can get through, but that we can define what the overlapping scopes are, and we get more of this, where like we can still have global styles that come through, and we can just set lower boundaries where things shouldn't go too deep. So it looks like this at scope, and we can give it a root, and then we can give it a lower boundary, or as many lower boundaries as we need. And here, from media to content, it will only style images that are between media and content in the DOM. If we find a content inside of a media, we're not going to keep styling. Also, it has this idea of proximity. So, like if we have light theme A and dark theme A, right now there's a bit of a problem where depending on the order we define them and the order we nest them, the second one always wins instead of actually paying attention to which is the closer one. We want that closer one. So it does that too. So there's a prototype in Chrome you can play with if you have Chrome Canary. So you can see it failing up top. And working down below. And we've just done that with some scoped styles in here after the no scope ones. So we've got from dark theme to light theme, any link, color it cyan. And do we have the alternate scope, or we're just letting it be global? Because the light theme is the global one, so why would we need another? And you can sort of solve this problem either way, either using those scope boundaries or using scope proximity, because this is the same basic thing. But instead of using a lower boundary, we're just relying on the fact that either the dark theme or the light theme is going to be the closer ancestor of the link, and so the right one will win when we get to it. So scope does those two things. That's the idea right now. Scope's a little bit farther behind as a spec, but we're ready for you to start playing with it. Here's just a media object quick. I'm not going to spend a lot of time on this. I'm not going to spend any time on it. But I just have in that scope, I've got some content that's outside of the scope but is nested. And I'm just saying, the image that's in scope, give it a border, and other images, or give it a border radius, and other images, let them be. So we're styling that without getting complex about our selectors, without maintaining any sort of naming rules that everybody on the team has to understand. So there is a prototype in Chrome Canary. We're also talking about some other things we could add here. Like we could add, it's in the spec, and we don't know if people want it. We could add a proximity combinator, sort of like a descendant, like we've got the single bracket for the direct child. We could use this for descendants where we want to pay attention to proximity. That's an option. We could build that. Also, there's some talk of having a selector syntax. The main advantage here, so those two would mean the same thing. It's a little bit more obscure, but you could use it in query selector all in JavaScript or something like that. So maybe it has some advantages, but it's also a little harder to read. So some things still to play with, and we're happy for you to play with the prototype and give us some feedback. And scopes and layers have some overlapping ideas. I mean, I think the first attempt at scoped styles tried to sort of merge these two ideas together, and we tried to split them up. So you can have scopes that overlap layers. Layers are more about the intent, and scopes are more about what is the thing. And those are overlapping ideas. And the final one, I only have a few minutes left, container queries, which is probably the reason you came to my talk. And I think we've all dealt with this situation, roughly. You know, with media queries, we can respond to the size of the viewport. But what if we add a sidebar and throw one of these into the sidebar? The viewport isn't actually telling us what we want. It doesn't quite work. So container queries make it work. Everything, we can set up the containers that we have, and we can measure those instead of measuring the entire viewport. So people have been asking for that since before media queries were invented, and it's finally coming. And we want to be able to nest these containers and respond wherever we are. But there was a big problem with layout loops because of normal flow. In CSS, the content sizes the parent, and also the parent sizes the content. And somehow we're supposed to measure one of those and respond to it. And it's just an infinite loop. So in the past 10, 15 years, browsers have been laying the groundwork to make this possible. And more recently, there were two main proposals for directions to go, and we mostly went with David Barron's proposal and just made some adjustments there. But the first step is that we need to define containers. And those containers are going to have to cut off that loop. So we can say, okay, the sidebar is a container I want to be able to measure. Just what are the things on the page that I need to measure? And those things aren't going to be, they're going to have to lay out their children without being laid out by their children so that we don't get that loop. So we have to turn off content sizing for those container elements. And there's a way to do it in CSS already. The contain property, we can contain size, and then contain layout, and then contain style. And we're going to need all of these, but you don't have to memorize all of them. 2D containment's a little too restrictive, because if things, it's where we get into this situation, right? If we try to ignore the content entirely and just specify the height and the width, we're going to run into problems. Things overflow. So we need one size to remain measurable and the other side to remain adaptive. And this was a big problem. This is the big thing that we've been trying to solve. Here be dragons. Single access containment. I think that's what Robin was talking about. Yeah. And we already actually have this problem in other places. And this is the final breakthrough was Ian, whose name I can't remember in the moment, pointed out that there's already situations with floats where the height of an element can change its available width. So the taller that item gets, it switches to the next space, and then it has a different width. And that's basically the same layout loop that we're dealing with. So that means we already do have a way to solve it. There was a moment, well, I'll get to it. There's some other problems, but there was a moment, I think of this Zeno's paradox, this idea that, like, in order to get somewhere, you have to go halfway and then halfway again and halfway again. And each time, that takes a set amount of time. So how are you ever going to get there if you just have to keep going halfway? And as engineers, we usually just like take 3 steps and we're like, got it. But for browser specs, we can't do that. We can't reach out and grab it. We actually have to prove that it's possible to get there. And so there was a moment last summer where it was like, we had a working prototype and we still thought the whole thing might die. And it didn't. We made it through. Container queries are coming. And it all is based around this. We can we now have a contain inline size that just contains the inline dimension and allows the block dimension to keep growing. There is no contain block size. It wasn't possible to solve it that way around. There's just too many complications. So we can use contain size to do both, and we can do the inline. We can't do the block on its own. But this is a little too complicated to remember. We don't want to have to write that every time. So instead, we have a container type. We say container type size or inline size or none, and we get a container that then we can measure. And we can nest containers as much as we need to. The main rule is that each container can, or anything that wants to measure a container has to be inside of it. So a container can't measure itself, but a container can measure the next container up. Yeah, somebody made a 36 chambers with all the containers and getting the different colors depending on what size. So we can nest them as much as we need to. And for querying them, we have this @container rule, and then we can say what we want to query about it, and each element inside of that will match and then find its container and respond to it, much like a media query. So we can say a container has container type inline size, and then we can even say another container inside of that, measuring it, should respond to it. We can also name containers so that we can jump up the stack. If we don't want to measure the next container, we want to measure something farther up, we can give them names and say a container with the name of sidebar that is also a width of greater than 30 ems. If I have one of those, measure it and apply these styles. So in order to find a container, we have to match every element and then look for its nearest ancestor that has the right container type and optionally the right container name. So we go find the right container and then we measure it and then we can answer the query. And all this works. I already showed you this demo. It works. And it's pretty close to coming out. This is another demo that somebody on my team made. You can go play with it if you want to. But each quote responding to its space. In some situations, like a grid or Flexbox, this is Flexbox, you're going to want to put containers on every item because there's nothing to measure, like a grid area or a Flexbox space. There's nothing to measure there, so you need to put a container in it and then something in that container so that you have something to measure and something to measure it, but it works. I just think of some of these are things that need to carry their container with them, like a turtle. So some components, turtle components, carry their containers. Max Bock made this great, you can drag books into the featured section, and it's the same component, and it's just responding to its space. There's a bunch of these. Yuna has one where the SVG icon is changing and the button is changing around it. This one is from Jay. That's just measuring a container getting bigger and adjusting what's inside based on that. Somebody said that my containers didn't hold water, so I wanted to prove them wrong. It's not all water, but there is some. And again, there's a prototype in Chrome Canary and also now in Safari Technical Preview. And both are planning to release it soon, and Mozilla is working on it. So again, later this year and into next year, all the major browsers are going to have this. And there's more to it. Oh, we can also use a supports rule to check for a browser that doesn't support container type and put fallback styles in there if we want to do media query fallbacks or something like that. And there's a polyfill being maintained, so this can also work now, backwards compatible. And there's more. I mean, we talk a lot about size queries as sort of the thing, but there's a lot more we can do here. So we're getting container query units. So if you have a container and you use these units inside of the container, and I think the units will also treat the viewport as a fallback. So CQW, CQH, CQI, that's container query width, container query height. We can use these as units. CH was already taken, so we had to add the Q in there to make it work. But let's go to a better demo. So this is a demo that Scott Kellum put together. That these are all using exactly the same code, but they're using a container query unit on the typography so that the larger boxes get larger type. Again, container query units are also being supported in all the prototypes and will be coming out soon. But then there's also non-size queries, which are a little farther behind. So we're going to get style queries, which let you look at a container and say, what is the value of this custom property on the container, and respond to that. That should be pretty cool. But a little farther behind, we maybe are going to get state queries. Is this thing position sticky and currently stuck? Respond to that. So I think there's a lot more to container queries than just what we were expecting from them. And all of this is building on previous existing CSS and the Cascade. It's all building on what's there, making styles even more reusable, even more responsive to more different things. You know, responsive web design became a thing in 2010 with Ethan Marcotte's article. But that was based around all these percentages and sort of removing intrinsic sizes from everything and putting it all in a percentage-based grid and forcing that from the outside. And we're trying to get to a different approach that Flexbox and Grid and Subgrid and min and max content, all of these other tools are now giving us a way to access the intrinsic sizes of things and then respond to that instead. And that's what we're trying to build on. What Jen Simmons is calling intrinsic web design. So we're mixing fluid and fixed. We've got different stages of squishiness. If you haven't played around with the way that grids grow and shrink at different rates, we've got truly two-dimensional layouts. We've got nested context. We can put Flexbox inside of Grid and the other way around. Things expand and contract, media queries, container queries, as needed. So even more responsive and reusable, but at a component level, and then working out. Our medium is not done. Our medium is still going through radical changes, and there's more coming. Thank you.
All right. I'm going to come this side of you. I'm going to come round here.
All right.
Let's perch on here. I wanted to stand on this side of you because sometimes they gesture at me.
Oh,
like
yeah.
From the they go.
That's
they
terrifying.
Go like that. That's the gesture we don't want to see. But I think maybe I've only got time for one question. Okay. And so let me make sure I get it right. So there were loads of questions, and it does seem like an exciting time to be alive on the web. It's very exciting. So the one question I wanted to pose, since we don't have too much time, is how do you write CSS? No, hang on. No, hang on. No,
slowly.
Sorry. How do you write CSS? So, in other words, given that we've got all these tools and we've had these abstractions like Sass and these different workflows, with all of the, how close you are to all of these evolving parts of CSS, what's your approach to writing CSS? Do you just do things plain vanilla CSS? Vanilla CSS, is that a thing? Oh, I don't want to say that out loud. Or are you using tools and abstractions on top?
I use Sass. I think of, so there's some ways that Sass has inspired things that moved into CSS, like variables, whatever, nesting is going to come. And that's very cool. But it's sort of like Node is useful on the server and JavaScript is useful on the browser, and those are both JavaScript, right? Yeah. And I think of Sass the same way. It's useful on the server. There's a lot of things that we can not make the browser do. Yeah. It's great for storing our design tokens and then generating custom properties that we'll use in the browser when we need them, but sometimes we just need them static, so why bother? Yeah. So I use Sass quite a bit to organize things.
Do you think that'll ever go away? Do you think
I don't think so, because there's no reason for CSS to run on the server, and there's always going to be server-side problems. So we're going to have both servers and browsers, and so it's useful to have a tool that works in both.
Sounds like a good answer to me. Awesome. Thank you so much for a really enlightening talk. I thoroughly enjoyed it. I think everyone did as well. So please, a huge round of applause. Miriam Suzanne.
Thank you.
Thank you so much.
And find me out there if you have other questions.
Yes.